The sidechain input for the envelope follower of Nell finally works, and it sounds like this. As you can see, it currently takes the sidechain input from this drum break, which is silent itself. So in this video I'm going to tell you how I did that, because last time I made a coding stream I got very confused about the things that I had to do in order to make this work, and then I had to take some time privately to figure this out, and now that I think I have figured it out without bugs, finally I can present the solution. But before doing that, I want to tell you all to come to my Discord group, in which I currently host a little challenge in which you are all invited to partake in, at least those of you who are on Windows, because there is no Mac build of this plugin yet. Basically what you will find when you go to my Discord group is the current build of this plugin, so you can already check out some of the new features like the feedback control, and the challenge is that you come up with a good color scheme. In order to do that, you go into the menu to colors, and then you select whatever thing you want and you change the color of that thing. And once you've figured out a color scheme that you like, you can just send me it, and then I will give you €12 via PayPal as a prize. In order to give me your color scheme, you have to go to user, to your username, to app data, to roaming, to Mugala, to Nell, and then there is the Nell settings file, which basically has all of the default values, including the width and the height of the interface, by the way. But yeah, you don't have to manually change things in that file, because the file is being changed when you are making changes in the plugin. That's how it works. And then you give me the file in order to give me the changes. And then if your changes are cool, then you get €12. Okay, so let's start with the coding sidechain stuff. I decided to give this a top-down approach. So we are starting at the modulator because it's the most practical part of this whole thing. And then we are kind of going more low level with each step. So here is the modulator header with all the modulators in it. And there is the envelope follower. And there is the processing method. And now the processing method has the input samples and the input sidechain samples, the input channels and the input sidechain channels, just in case that the sidechain bus has a different amount of channels than the other bus. I don't know if that's possible, but I would have to test it in all doors to find out if it's consistently the same. So if I could take away these two things, only have none channels here. So since I'm not quite sure, I just decided to have both of them here. So the envelope follower works like this. It prepares the gain buffer in case there is some smoothing. Then it synthesizes the envelope from the input samples. Then it makes sure that the modulation cannot clip with some smoothing. And then I'm mapping it to -1,1. Before it was always mapped to 0,1, but now I changed it to -1,1 due to different reasons that I will talk about in a different video, I guess. In the video that I will make when I officially release the plugin and update the VST file on GitHub as well and stuff. But basically the only difference that I made here in this class is that I don't directly use the samples array that is given by this function, but I'm starting it off with saying that the samples array that is being used is defined by the Sidechain Enabled boolean, which is now one of the input parameters of this modulator. So this modulator has a new parameter basically. So in my ProcessBlock vibrato method in the audio processor, you can see that if the envelope follower is currently selected, it does get a new parameter output. And then for the processing, I give it the samples main read, samples sidechain read, the MIDI buffer, the position info, the number of channels, the sidechain number of channels, and the number of samples. Everything else still works the same, I guess, mostly at least. Well, I will talk about it now. Now going back from the top-down approach a little bit, I want to talk about my sidechain header before going on. I found it very complicated to handle the existence of the different buses in ProcessBlock itself. It's just easier when you have all of that laid out in a single struct. So I decided to make such a struct and call it sidechain. Maybe it's not the best name because it also contains the information about the main buffer, not just about the sidechain buffer. But yeah, I will probably rename it to something else. This basically handles the existence of the two different buses that can exist. For example, there is bus main, there is bus sidechain. There are buffers for the main buffer, for the sidechain buffer, for the upsampled buffer because of the oversampling, divided into main upsampled and sidechain upsampled. And then there are write pointers and read pointers for all of them. the number of channels, which means the number of channels of the main buffer, the number of channels of the sidechain buffer, and whether or not sidechaining is enabled or not. All these things get pretty generic default values, and then I'm getting started. Now let's go back to ProcessBlock really quickly. When ProcessBlock is being called, then I'm doing the things that people always do, which is clearing channels that shouldn't be there with these lines. And then I'm asking if the current build is a standalone build by checking if wrapper type is wrapper type standalone. Wrapper type is the member variable of audio processor. You can just use it like that. And then I'm passing this information alongside with the audio processor and the buffer, which contains all of the information from both the main bus and the sidechain bus into update buffers from the sidechain object. That is why I showed you the start of ProcessBlock, so that you know why this method is in place. So you can imagine it like this: at the start of every block, I'm just assigning all of the values that need to be assigned already, so that I can work with it more nicely in the upcoming code of ProcessBlock. So it works like this: I'm getting the main buffer by calling on the audio processor get bus, is input is true, and the bus index is 0 because it's the main bus, and then I'm getting the main buffer. In order to get the main buffer, which is an audio buffer, you just take the main bus and you call get bus buffer on the whole buffer. And yeah, as you can see, you can just do this. It will not perform a copy, but I think it will just pass on the pointer to the underlying audio data. At least that's what I saw in the documentation, and I also didn't notice audio allocation hiccups. But please correct me if I'm wrong anyway. So then I'm getting num channels, and I'm putting the write pointers and read pointers into samples main and samples main read. Now there are a lot of cases that have to happen in order for sidechaining to be true, and if it's not true, then the sidechain buffer will just be the main buffer as well. I found that to be a pretty cool solution, because it means that the upcoming code can just work with the sidechain buffer, thinking that it's the sidechain buffer, but it's not actually the sidechain buffer, but just the main buffer again, so that I don't have to write different code for these different states. The code can just work with it, whatever. And I'm setting enabled to false, so that later, if any part of the code wants to know if sidechaining is currently a thing, then I can just give it this information. Now about these states, the first layer is if this is standalone. So if the build standalone is currently selected like now, then obviously there cannot be sidechaining, because JUCE just didn't implement their standalone host to know what the second input is. So normally when you're making a sidechain project in JUCE, you cannot use the standalone build anymore, because it will just crash at start every time. But by doing it more or less like this, you can make sure that it will still work, because then it just has a fallback behavior for standalone. Now the next thing that you want to do is getting the sidechain bus in the same way that you got the main bus, but with the index 1. But then you have to check if the sidechain bus is null pointer, because obviously this returns a pointer and not an object. I'm not quite sure in which case this can actually be null pointer, because I was not able to trigger this to be null pointer. If you know more about this, then let me know in the comments. Anyway, then going on, if the bus sidechain actually turned out to exist, then you have to check if it's enabled as well. And of course, this is often being determined by your inputs in the door itself. Like in Cubase, you can click on a little button on top of the interface of a plugin in order to enable or disable sidechaining. And in Bitwig, you just have to select a sidechain input, and if an input is selected, then it is also enabled. And if not, then not. That's how it can work in two different doors. But yeah, there was always some mechanism that triggers this to be enabled or disabled. And if it's enabled, then you can actually say, okay, the buffer sidechain is the bus of the whole buffer. And yeah, the rest is pretty much the same as with the main buffer, except that you set enable to true, of course. Now we are back at the ProcessBlock method, where I think everything else is just the same as far as I can see, except that now at certain places you just have to make a difference between the main buffer and the sidechain buffer. Like here I'm getting just the main read because it's used to save the dry signal in DryWet. Of course, in a DryWet control you don't need the sidechain information, you can just only work with the main bus. So you have to be a little bit careful to make a distinction between these things when you start working with sidechain inputs. Then there is this part of the code where I'm checking checking if MidSide mode is enabled and the main bus has exactly 2 channels, in which case it shall MidSide. Before I had sidechaining in here, it always worked like this. I encoded the samples to MidSide, I processed the vibrato, and then I decoded it again so that we have the normal channels again. But now that there is sidechain stuff, I check if sidechaining is currently enabled. So that's why I added this bool basically. And if yes, then the sidechain samples are going to be encoded as well. Now you have to make this little if clause here, because imagine that sidechaining is disabled. That would mean that you encode the main samples and then you encode them again because the sidechain samples are the same. Yeah, maybe that's a little bit of a peculiarity about the way that I handle this, but I think apart from that, it is a really good solution. And yeah, if there is no MidSide, then it's simple. Now let's look at ProcessBlock Vibrato. There I also pass the buffer with everything and not the main buffer and the sidechain buffer separately. If oversampling is currently a thing and I'm not debugging the mods buffer, which are just macros that I have in this project, you don't have to care about that too much, then I'm performing oversampling on the whole buffer. I had to rewrite my oversampler a little bit to always work with a maximum of 4 channels instead of a maximum of 2 channels. And then it will return a buffer and the information if oversampling is currently enabled. Just before returning from this function, I am using oversampling enabled in order to find out if I have to downsample the entire buffer again. And now as you can see, right after oversampling, the sidechain object does something again, which is set buffer oversampled. Let's see what this does. So this gets the whole buffer of everything but upsampled, and now it just does similar things as update buffers already did, which is assigning these things from the main bus, and if sidechaining is enabled, then also doing that for the sidechain bus, and else assigning the sidechain variables as the main variables. This looks a little bit simpler than the other method because we have already checked for all of these cases, so they cannot have been changed in the meantime, so we can just assume that it's now enabled or not, which is kind of nice. So now that we have the upsampled buffers ready, we can work with that in the upcoming code. For example, here in the modulation process block that I showed you earlier, we give it the main read and the sidechain read are now separated buffers, so I can easily work with that in my modulator code base, which is nice. I want to show you some other challenges that I ran into while doing this, just in case that you want to implement sidechaining yourself and you might run into similar problems. For example, at some point I decided that I want to work with double audio buffers, so I make a distinction here between audio buffer F and audio buffer D. And in order to get the host to actually ask for audio buffer D, you have to define the function supports double precision processing and let it return true, which I did here, as you can see. However, I'm not sure if this is all that you have to do, because I noticed that it just often still calls the audio buffer F method. So I defined the audio buffer F method like this, that I'm like artificially creating an audio buffer D by copying all the float samples into the double buffer and then calling ProcessBlock with the audio buffer D myself. And then at the end, I'm copying that back into the float buffer so that it actually exists in this buffer, the data. I'm not sure if this is the recommended way to make this work, but that's how I did it. And one of the challenges that I had here was that audio buffer D always has to have the same size as this buffer, so that the behavior in the upcoming ProcessBlock method is consistent with whether this whole function is being called or not. I did that now by doing this in prepare to play. I just said, okay, the audio buffer D has a size of 4 channels and the maximum buffer size. It doesn't keep its existing content. It definitely clears all the extra space so that it's just a clear buffer, and it doesn't avoid reallocation so that all of the values are next to each other in memory. And then in ProcessBlock itself, I'm also using SetSize, but the difference here is that I'm not clearing, that I'm keeping the existing content, and that I'm definitely avoiding reallocation. So it's basically the opposite. And this works because num channels is always smaller or equal 4 and num samples is always smaller or equal block size. So this will definitely never reallocate as long as the hosts are properly implemented. So this will not reallocate. It will just how this buffer works in the upcoming code. And I'm always doing that at the start of ProcessBlock so that these two buffers are aligned with each other, so that this 2-dimensional for loop is as simple as I can get, and the other one as well. So in most cases, this will just do absolutely nothing, but just when the sidechain inputs have changed, this will do something. I just wish that the JUCE team makes an alternative method for SetSize, one that doesn't have so many if statements in it, one that is just purely made for situations like this, so that I can skip all of these checks and just be like, yeah, I want to use a SetSize that is specifically made for real-time purposes. I don't need to check if that's the case every time. That would be pretty cool if they did that. Always having to have all these checks, that makes no sense to me for something where I just know that I always want to have a specific functionality. Apart from that, I'm pretty happy with functionality of audio buffer. It's just one of these JUCE objects that you learn to appreciate more and more the more you learn about it. So there are some other things that I want to talk about before actually showing you some of this in practice. For example, here there is the constructor of the processor where I have this method call MakeBusesProperties. So this returns a buses props, which is an audio processor buses properties. Normally in a producer based project, you have all this very convoluted looking stuff here in the constructor, but I decided to move everything that I need into this free function so that the initializer list just looks much more clean. And yeah, I'm adding an input bus, an output bus, and if my has sidechain macro is true, then I am also adding another bus if we're not in the standalone app. I would have loved to put this method into my sidechain header because I feel like this is totally a functionality that belongs into this header, because this header is like now the header that tries to deal with all of my buses problems. It's where I want to outsource all of these types of problems. However, that doesn't work because BusesProperties is a protected member of the audio processor class. So lately in the JUCE forum, I just asked politely if they could put that to public so that I can use it in my header. And I got this response from Roig in which he showed me a trick how to get the protected member from a class publicly by kind of creating a dummy processor and then, well, doing all this stuff. However, I decided against it because I felt like it would make my code base look more confusing. And the whole idea of this header file was to make things look a little bit less confusing. So even though I really appreciate learning about this solution, I really can't use it. I got some support for this request, but I don't think anything has changed so far. So yeah, that's why it's not in this file. The CanAddBus method is later being used in the process of switching from Sidechain Enabled to Disabled or the other way around. And that's why you have to implement this if you want to have sidechaining. And I'm not sure if it's totally correct, but I think it is. So the way I'm doing it is I'm saying if the wrapper type is standalone, then false, we cannot add a bus, and else you're just returning is input true or false. Well, and I also have my sidechain macro in here just in case I want to turn off all sidechain features all at once for some reason, maybe for debugging or something. So let's quickly talk about the method IsBusesLayoutSupported. I just have it working like this. I'm defining what mono and stereo is, what the main in and main out channels are. They have to be the same. They have to be either stereo or mono in order to be anything. If any of this fails, then it will not load the plugin. And then if sidechaining is currently a thing and we are not in the standalone wrapper, I'm getting the sidechain input bus, and if it's not disabled, then I'm saying it has to be either mono or stereo, and then if it's not the case, then I return false, and if everything works, then I'm returning true. Now let's run this in standalone and find out what happens. Envelope, follower, sidechaining is officially enabled here, but it's not really enabled. It's definitely taking the main input. And the reason is because of my sidechain object, which says that if it's standalone build, then it will just take the main bus. So you can see it in action here. It works. You can still debug your plugin in standalone when doing that. Now I want to show you something about debugging sidechain plugins, because I found that to be particularly challenging. Certain things are just specifically challenging in a JUCE project, and I'm talking about all of the things that require you to have a different behavior between standalone and plugin builds. One of these things, for example, is when you have to work with project positions. If you don't come up with default project positions and BPMs and stuff like that for the standalone build, then you always have different behavior if you are running your plugin in standalone or in VST, and that can get very annoying. And it's similar to sidechain inputs, because you want to test if your sidechain inputs are working, but the problem is there can be problems at initialization already, and then the plugin crashes before you can even start the debugger. That can be really annoying. So let's quickly try to trigger one of these cases. I think I can do it like this by just moving this code down here instead. So now we have a method that looks pretty similar. It almost looks like it could do the same thing that it would normally do. Like you wouldn't even see at first glance what the issue is here. And now we can run this as a VST3 build. And now let's run this in Bitwig. So we load the plugin, we remove the sidechain input, we add the sidechain input again, and it crashes. So now I just want to load the debugger now. So let's activate the plugin again. Okay, that works. Open interface, select window, boom, attach. Now we can check why it breaks. So we go back to no input. Oh, and we can see the host is misbehaving. The plugin must be deactivated before setting new arrangements. So yeah, this is just an ongoing Bitwig bug that I think you will not be able to do anything against that. I asked in a JUCE forum if anyone knows this issue or knows a way around it. And yeah, the only answer that I got was that when you comment out the JUCE, then the JUCE will not happen. Okay, I mean, I don't care much about the JUCE anyway, if at least the plugin doesn't crash and doesn't make any issues or anything like that. But it would be cool still if it was fixed on Bitwig's side, because if the VST standard says that the plugin has to be deactivated during sidechain change, then I think that should just be the thing that happens. Also, it might make more plugins work stably in Bitwig. You know, I've been a Bitwig and a Cubase user for a much longer time, and I just know that plugins are less likely to crash in Cubase, and I think one of the major reasons is because Cubase just applies the rules that they also set for the standard. But Bitwig always tries to go more fancy than that. Like in this example, trying to make it possible that a sidechain input can be activated and deactivated without deactivating the plugin in the meantime. And yeah, it can cause crashes and JUCE. In this case, just a JUCE, because I found a way around it. But still, we wanna still know what the crash is. So let's continue. So that worked. Now we go back to input, boom, and it will give us the same JUCE again, continue. And now we got the crash, and the crash comes because audio buffer now has 4 channels and buffer has also 4 channels. Then what is even the issue? Okay, I'm not sure. But this for some reason didn't work. So as you can see, it can be pretty hard to actually reason about the issue. Like you can not immediately see what's going on even if you are using breakpointing. I think it was actually easier to see the last time I debugged this, because I could clearly see that there was a difference in channels in these 2 buffers. Anyway, you can imagine if something in the background is hot swapping a certain buffer, then you could get in trouble in ProcessBlock. So that's why I put it in the start, so that it always definitely works. Since then it works pretty fine. I also had some moments where it would just crash on Init, which is because at the beginning I wasn't sure what kind of channel layout I should select here in the prepare to play method for my audio buffer. Because if you are looking through all the different options, there is get channel count of bus, which returns the channel count of a specific bus, main or sidechain. But you know, you're trying to make a buffer that has the channel counts of all buses, so you would have to add them together to use this, I guess. Then there is get main bus num input channel, so that's basically like using get channel count of bus with index 0. Get num input channels is a deprecated method, so we shouldn't even start reasoning about it, I guess. And then of course there are also always the output channels, so you always also have to think about them when designing complicated channel layout things. So that can also complicate this whole thing. Then there is get total num input channels, and yeah, I'm still not really sure if I should have just used that, but in the end I just settled for the number 4, just to be sure that it's always more or equal. And yeah, when I was still using some of these other methods in order to figure out what the buffer needs, I often had this issue where it would just crash on initialization. And what really helped then was not using Bitwig but Cubase for debugging, because Cubase can be run as a debugger directly. If you are new to JUCE and you don't know how it works yet, then just follow the steps that I just did and then select the place where you have a door that can be used as a debugger by clicking on browse and then selecting the Excel file of that. Okay, and then you can run it and then it will debug the plugin with the application. Normally I like the debugging workflow in Bitwig more because you can almost hot swap a plugin. You just have to deactivate it in Bitwig, build again, and then you have to activate it in Bitwig again without having to close and open the door. But in a case like this, I'm more of a fan of the Cubase workflow, where you can just run the entire door as a debugger, and well, and if you then open the project and it immediately opens your plugin as well, and then your plugin crashes, then you will see the crash report. So now I can select the project with nal in it. And yeah, it loaded up just fine. I can disable and enable sidechaining in order to find out if that leads to a crash. I can remove the sidechain input or choose a different sidechain input. Yeah, I have one sidechain input just with a mono sample and one with a stereo sample because I wanted to test if that makes a difference. In Cubase, it actually works like this, that no matter if you go in with a mono or with a stereo track, it will be converted to stereo if the main track is also a stereo track. That makes me wonder, I still have to test if this also works on a mono track. I will have to do that later. However, as you can see, all of the different cases work here, and if one of them didn't work and failed on initialization, then it would have gave me the exact point where it failed in my IDE, which is why it's definitely cool that there are still doors that do it the old school way, that let you put the entire door as a debugger into your IDE. It doesn't always help going with this more elevated way that Bitwig has, even though it is usually really cool. Alright, so I hope that this was helpful to some people who also want to implement sidechaining. Again, if you saw that I made some mistakes here and you would like to correct me about that, then please do, because I do feel like this is a very complicated topic and it's really hard to always know if you really thought about everything. That's why I try to make it more streamlined with this sidechain header, but it still might be that I forgot about something. And else, yeah, I hope you just enjoy now being able to make sidechain plugins that work pretty well, or maybe even perfectly, because I didn't have a problem with this so far. And yeah, see you next time.